We tend to think of artificial intelligence as this, I don't know, this impartial, data-driven force of pure logic. But what if that whole idea of objectivity is just an illusion? What if these incredibly powerful systems have hidden flaws, vulnerabilities that can be exploited, or even biases they inherit directly from us? Well, let's go looking for the cracks in the code.
So, I want to start with a question that really gets to the heart of the problem. How can a system, one that's built entirely on logic and data, be so incredibly confident, and at the same time, be so fundamentally, completely wrong? Because of this. Seriously, look at this. On the left, you've got a normal picture of a panda. An AI sees it, no problem, calls it a panda. But then researchers added this tiny, mathematically crafted layer of noise. That's the image in the middle. You and I can't even see the difference. But suddenly, the AI looks at the image on the right, and it doesn't see a panda at all. It sees a gibbon, and it's 99.3% confident about it. This is called an adversarial attack. And this one single stunning failure, well, that's our way in. It's our first big clue to understanding the cracks in the foundation of modern AI. To really get this, we need to look at where these flaws actually come from. So we're going to explore 3 core areas where things can go wrong: the biased data AI learns from, the ways its training can be deliberately sabotaged, and the really strange feedback loops that happen when it's released into the wild. Each one tells us something different about AI's weaknesses.
Okay, so first things first. Everything starts with the data. An AI isn't just born smart. It learns from all the information we feed it. And that leads to the first and maybe the most important rule. If your data is flawed, your AI will be flawed. It is the ultimate case of garbage in, garbage out.
One of the most common ways this happens is with imbalanced data. Get this, research shows that over half of all clinical AI models are trained using data from just 2 countries, the United States and China. Now, that means the model gets really good at making predictions for people who look like the people in those data sets. But its performance, it can just plummet for anyone from a group that wasn't well represented.
And the results of that biased data can be, well, pretty jarring. In a study on the language model GPT-2, they gave it some simple prompts. When they typed in, "the woman worked as," the AI finished the sentence with "a prostitute." But for "the white man worked as," it spit out a whole list of powerful jobs. Now, the AI isn't being malicious here. It's just a reflection. It's just repeating the biases it's soaked up from all the text on the internet.
And this effect is so real, you can actually measure it in the math of the model. In these things called word embeddings, the AI learns how words relate to each other. So it learned that the relationship between man and king is kind of like the one between woman and queen. Makes sense, right? But it also learned that the relationship between man and computer programmer was similar to woman and homemaker. It literally encoded a societal stereotype right into its core logic.
Sometimes the bias isn't about what's in the data, but about what's missing. Think about medical records. They've got your lab results, your diagnoses, but what about your access to transportation or your education level? These things are called social determinants of health, and they have a massive impact on our health. But when an AI doesn't see this crucial context, it might end up making biased recommendations for the very patients whose health is most affected by these outside factors.
So, okay, the data itself can be accidentally biased, we get that. But what happens during the training process if the flaws aren't an accident? What if someone wants to sabotage an AI on purpose?
Well, this is called a poisoning attack. It's when an attacker intentionally slips malicious data into the training set. And the goal here isn't just to trick the AI on one picture, like with the panda. The goal is to corrupt the entire model from the inside out, to fundamentally change how it makes decisions for everyone forever. It's like poisoning the well that the AI drinks from.
And this distinction is so important. Remember the panda? That was an adversarial attack, a temporary trick played on a model that was already trained. A poisoning attack is way more sinister because it happens during training. The corruption isn't just a temporary glitch, it gets baked right into the model's DNA.
Okay, so that brings us to the last stage, deployment. The AI is trained, it's out in the world, and now a totally new, kind of bizarre problem starts to pop up, a self-perpetuating feedback loop.
This is sometimes called the AI Ouroboros problem, the snake eating its own tail. Think about it. AI models are trained on the vast amount of information on the internet. But now, the internet is getting filled up with content created by other AIs. So the mistakes, the biases, the weird hallucinations of one generation of AI become the literal textbook for the next generation to study. Here is a perfect example. A chatbot just made up a fake name, Lars Hansen, for the creator of a search engine. Now that incorrect fact is just out there, on the internet. So the next big language model that comes along and scrapes the web for data might see that fake fact, assume it's true, and boom, it gets incorporated into its own knowledge base, spreading the error even further. And this is not some niche problem for a few chatbots. I mean, think about the systems we use every single day. Recommendation engines can get stuck in these loops, suggesting only AI-influenced content until our feeds just become these weird echo chambers. Search engines might start pushing AI-generated lies above real information. The very systems we count on for information are at risk of slowly polluting their own well.
So, after hearing all that, is it all just doom and gloom? No, not at all. Recognizing these flaws is absolutely the first step to fixing them, and researchers are working hard on ways to build more robust and trustworthy AI.
Here's a look at one attempted fix in action. On the left, you can see a visualization of a model's brain, and it's showing these sexist word clusters it has learned. Then on the right, that's the same model after a de-biasing algorithm was run on it. You can actually see the attempt to mathematically sever those stereotypical connections. It's like performing surgery on the model's logic.
But here's the question. Is this a real fix, or is it just a cover-up? One pretty critical research paper gave this approach a scathing name: lipstick on a pig. The argument is that these fixes are often just superficial. You might hide the most obvious bias, but the deeper statistical patterns that created it in the first place, they're still there, just waiting to pop up in a new, more subtle way.
And that means the real solutions can't just be simple technical fixes. They have to be fundamental, and they have to be ongoing. It all starts with cleaning up the source, better filtering to separate human from AI content, and a real, genuine commitment to data diversity. But it doesn't stop there. It requires constant human oversight, a process of monitoring, validating, and correcting these systems not just once, but continuously.
When you put all of this together, one thing becomes crystal clear. AI isn't some magical black box of objective truth. It's a mirror. It's a powerful, complex mirror that reflects exactly what we show it: our best data, our hidden biases, our deliberate manipulations, and the messy, chaotic feedback loops that we create. Which really leaves us with one final big question to think about. If AI is just a mirror of our world, faults and all, then the real challenge isn't just about building a better AI. It's about our own responsibility to create and curate a better, more equitable world of data for it to learn from in the first place. What does that reflection say about us?